Okay, so we did this little aside with an example to help us understand what exactly our derivative thing was showing. But now we're going to go back to actually working with this thing. So I said, think about p. I said, imagine you could take e to the integral of p, and imagine you wanted to take a derivative of it. But why did we do that? So we're at this e to the integral p of x dx times dy dx part again. So we're just continuing the same idea of how do solutions to these ODEs work. And we had determined that d dx of e to the integral p of x dx times y is equal to e to the integral of p of x dx times dy dx plus p of x times y. And so probably you're sitting here thinking, but why do we do that? Why does that matter? And remember, the type of differential equation we're trying to solve says dy dx plus p of x times y is equal to f of x. I don't actually want that underline to stay there. There we go. So this thing right here, dy dx plus p of x times y, is equal to f of x. From our ODE, if you just say dy dx plus p of x times y equals f, then I can replace dy dx plus p of x times y with f right here. And now I've sort of taken our differential equation and we've represented it in an easy to solve way. It doesn't look simple, but I promise it is. So we've got d dx e to the integral p of x dx times y is equal to e to the integral of p of x dx times f of x. And maybe this will feel kind of familiar to you from what we did last week, but in order to get rid of this d dx, I can just integrate with respect to x. I could sort of say, okay, I'm looking at d e to the integral p of x dx times y is equal to e to the integral p of x dx f of x dx. And then if I integrate both sides, like that, what I've got is e to the integral p of x dx times y is equal to the integral with respect to x of e to the integral p of x dx f of x dx. Or y is equal to 1 over e to the integral of p of x dx times the integral of e to the integral p of x dx times f of x dx. So I'm going to go back through those steps and kind of write down what happened in each one, because I know that it was a lot of stuff where I knew what the next step was because I knew where I wanted to go, but it probably felt like it came out of nowhere for you. So I said we have this nice representation right here, and then we just rearranged derivatives, and then we integrate. And then this part right here, the integral of d of e to the integral p of x dx times y is e to the integral of p of x dx times y, can be kind of tricky. So for comparison, just think the integral of dx is x, integral du is u. So the integral of d stuff is that stuff, is kind of what happened there. And then at the end, we just rearranged for a solution. Right there. Yeah, and this looks a little bit intimidating. Because you've got all these integrals hanging out all over the place. But if you know p of x and f of x and don't know y, remember our goal of all these differential equations is to find that solution y. So you know that you can integrate p of x dx equal to some stuff. You know that you can say e to the integral of p of x dx is easy to plug in. And then even if it's a mess, you could technically compute the integral of e to the integral p of x dx times f of x with respect to x. So kind of in this solution I wrote in a box, you just need to be able to find e to the integral p of x dx and this integral, and then you have a formula for y. So we changed solve the ODE for y to integrate known functions with respect to x. And a lot of this class is going to be just knowing how to look at a differential equation and then rearrange it in a way that it reduces to plain old integration for you again. So real quick, we're just going to write down the steps to solve this type of equation. And then we'll start doing all of our examples. So all that showed you how this method works, and now I'm just going to tell you how to do it. So if you're given this differential equation, dy dx plus p of x times y is equal to f of x, is where you have to start. So kind of step zero, zero step, rearrange to standard form. So just remember that part. But if you're given dy dx plus p of x times y is equal to f of x, then you just need to compute e to the integral of p of x dx. And then multiply both sides. By e to the integral p of x dx. And, well, actually, we'll just make it its own step. Undo chain and product rules to get d dx of e to the integral p of x dx times y is equal to e to the integral p of x dx times f of x. Integrate both sides. And here it's going to be important to remember the constant / initial conditions issues from separable equations. I know that can take a little while to get used to. And then note that the only derivative we have in this equation is with respect to x. We don't have dy dx. So some people will think to try and integrate with respect to y, and that's not what we do here. So just be careful about that. And then finally, just rearrange to get your solution. Y equal to some stuff. Those are the steps that we'll use to solve this type of problem. One thing that I don't want you to do is to see a linear equation and then immediately plug in this formula. I understand that I showed you how to get to that formula, but that's not a very transferable skill. So this idea of having this integration step is already familiar from separable equations, and it'll continue to come up. So showing that you really understand how it works is what's important here. And we'll go ahead and show that in a few examples coming up.